Thank you very kindly. Welcome. One quick question. I'm curious, how many people have ever worked with Project Jupyter before? Use Jupyter Notebooks. Okay, great. So about half. About half. We've been working a lot with the project, with Fernando Perez and the rest of the team. I'd like to present some about Jupyter in general, but then also show examples of a new medium, how we're working with this at O'Reilly, and some ways in which I think it can be used in a lot of different organizations, be useful for data science teams in general. And also explore a bit more about how Jupyter and Docker work together. We have some tools that we work with for creating Docker containers that we use for our authors now. So there's something new called Launchbot. And then when we go into production, we're making use of Jupyter, Docker, Mesos, and some other open source projects all together in a distributed framework. So I'll show what that architecture looks like and really how you cross from developing something locally on your laptop into something that's deployed at scale. And also, please, any questions, if we're going along the way, I'd love to be able to help out and answer questions, so feel free to ask. So Jupyter is a project that's based out of University of California at Berkeley, at the the Berkeley Institute for Data Science. Fernando Perez is also involved with, I believe, Lawrence Berkeley, a physics research lab. This project came out of something called IPython notebooks. So you may have heard of IPython notebooks much more before. But the notion was that it was evolving to include a number of different programming languages. We'll cover some of that. There's currently more than 50 different environments that can be used in this. So Project Jupyter, here's a link for it. I can show that a bit later. But the project itself has been gathering a lot of momentum. And the core team is shown here. Fernando Perez and Brian Granger are the two leads. So respectively out of UC Berkeley and Cal Poly San Luis Obispo, which is also my hometown. A number of other people have been involved, in particular Jess Hamrick, Kyle Kelly, we've worked with, Carol Willing, a lot of these folks here. And there's a much larger community as well. These are just the core team that's organizing it. So as far as resources for Jupyter, we'll have the slides. This will be available. But if you want to follow along, there's documentation here at Read the Docs. And is that readable up there? I can expand this a bit. So this is some good documentation about the project as far as installation configuration, different things that you'd want to do with it. Other resources, there's definitely some very lively discussion groups among the core developers, the different people contributing, and so that's based off of Google Groups. I highly recommend that as a resource. Boost this up a bit. And also increasingly using Getter. So it's kind of like a Slack, like IM chat, based off of Get, or hosted by GitHub. But that's being used for troubleshooting. It's also used for some of the community events. There's been different Jupyter Day events in the US, a few of those in Boston, Atlanta, San Francisco, et cetera, Chicago. I'm not sure if there's been any Jupyter Day events yet in Europe, but there should be. There should be some planned. But it's a very, very lively community. As far as events, here's a Google Calendar for that, just showing what's coming up. And it tends to go along with a lot of the PyData events and other related ones. But we are working, O'Reilly is working with Project Jupyter to help build out some of these events. We've been sponsoring some of the Jupyter Days regionally, and we'll be looking to do much larger events as well. So I should explain some of this before I go on. I realize I just kind of jumped into it. But about half the audience has seen Jupyter, so half the people haven't. Jupyter is a way of having a notebook. So I can take and have, on my browser, sorry, on my laptop, I can have a web page which includes some rich text, like for instance, some text, some links, some photos, etc. But then I can also have code cells. And in those code cells, I can associate which kind of language I want to run. So it might be Python, it might be R, it might be Scala, any kind of a language that has a REPL associated with it. So any language that has an interpretive, interactive environment, generally speaking, you can hook that up to Jupyter. Now, an interesting thing, though, is Jupyter at its heart is a suite of network protocols. And the idea is, if you think about HTTP is essentially a network protocol for sharing the semantics of manipulating files, reading files, writing files, deleting them, etc. But doing that remotely over a network. So with Jupyter, it's a suite of protocols for the semantics of working with a REPL. So Python has the read eval print loop, and so when you type something in the Python prompt, it evaluates it, gives you back the answer. So with Jupyter, you can have the kernel running that REPL, that read eval print loop, remotely over on some sort of server, and then over the network, you can send code and get the results back. And the results are rendered inside of a web page. So there's a few different levels to Jupyter, but it's essentially, at its core, it's about this network protocol. There is also a web app. We'll show this running here. And the idea is that you run on some sort of server, it has a web app, and then the browsers will hit the endpoints there, hit those web pages. And then there's also the notebook aspect to it, which is what you see in your browser. The notebook was one of the latter parts that was added, and Fernando Perez, who created this, he jokes that it was a good way to distract himself from completing his dissertation. So he took a little bit extra time to get his PhD done. Let me go through here. There have been a few projects that have been added recently to Jupyter. The notebooks became very, very popular, and that's expanded. I'll show some references to this, but currently there's over 300,000 public notebooks on GitHub. And we see this a lot in academia, where notebooks are increasingly, you can think of them as being an alternative to creating textbooks. I work at O'Reilly, we're a publisher, but we recognize that the economics of publishing books is not what it used to be. And in particular, textbooks are very, very difficult. I see this increasingly. It's hard to really justify putting the time in to create a textbook if you know you're probably not going to get paid much money for doing that anyway. On the other hand, you can prepare lesson material, exercises in Jupyter Notebooks very, very conveniently. And it's simple to publish. It doesn't require a publisher really even being involved. It's open source. So we're seeing, at least in the US, we're seeing where professors are more and more moving their material, their class materials, out to notebooks. And this is why we're really interested at O'Reilly, because effectively it's a kind of publishing medium. And to that point, there's a couple of great projects. One of them is called Jupyter Hub, and here's the GitHub repo for it. But Jupyter Hub is a way of having a collection of servers, such as at a university, and then the different courses being able to subscribe to the services. So it's a way of managing a distributed Jupyter environment, and being able to base sizable courses on this, being able to have some auto-graders. So there's NBGrader that Jess Hamrick created, where you can assign classroom exercises, but then have some automated grading and tallying of scores. There's also quite an effort among people working in education to understand how to leverage Jupyter. And so here's a Google group that's dedicated to education in Jupyter. One of the main people that's been leading this, her name is Lorena Barba. She's from Chile, but she's a professor in mechanical engineering at George Washington University in DC. And also, she's on the board of NumFocus, which is behind Python. Lorena has been one of the main theorists about how to really leverage Jupyter pedagogically, how to really make the most out of it in your courses. And we've been working with Lorena very closely. There's a new project that's called, new project. There's a few new projects. There's one called Jupyter Lab, which is really just an alpha preview, but I have seen some good demos on this. And effectively, it's like an IDE. It has a kind of plug-in architecture. So if you really, really want to, you can put Vim in here and have Vim as your code editor. There's a lot of different kind of plugins for different software. But effectively, it's a way of having like a workstation that you could have on your laptop, but then also be able to collaborate with other people working on code. So I think that Jupyter is interesting because it provides a different look at how to do collaborative development of software. I think it's an interesting alternative or an evolution beyond what's currently done with IDEs, such as Eclipse and IntelliJ. And we'll cover a bit about that. In terms of different types of environments that are being supported, there's a list here of Jupyter kernels, and I should zoom this out a bit so it's a little more easier to see. But for the types of environments that are available, there's a number of different kernels. You really just pick which kernel you're going to use. Typically try to use one of the later versions. Obviously, Python it's built into it. So Python 3 and Python 2 are built into the default kernel. But then there's plenty of others, whether you're working in C# or working in R. Here's actually the R kernel. We use this a lot. Sage Math has been using Jupyter a lot for their materials. F#, Go, JavaScript, Ruby, Julia, Scala, et cetera, et cetera. Currently, more than 50 of these. We've evaluated, I don't know, probably about a dozen of these so far. We're working with a number of different authors who are creating tutorials in Jupyter, and then we publish those. So we also have a software practice that's evaluating, are these kernels really ready for production? So there's a growing list of different projects here for different types of environments that are being supported with Jupyter, but also there's some really great tutorials. Safia Abdullah has been leading some tutorials at Jupyter Days about how to create a kernel. So if you have a specific environment that you're working with or some new framework that you'd like to integrate here, really it's about a half hour's worth of work to be able to integrate a new Jupyter kernel. Okay, so let me move into more examples and show what this is about, how we use it. Less Guessing had a question recently. There was a comment online from Subash D'Souza, who leads a lot of the big data meetups in Los Angeles. And he was talking about data storytelling. And Les had popped up and said, you know, all this talk about storytelling, it's usually about some sort of JavaScript package used for visualization. But it's not really storytelling in the sense of using video as a narrative or other types of medium that we generally use when we're making movies or making art, different types of more advanced type of storytelling. And so that got me thinking. We've been facing this problem at O'Reilly for a while. Number one, about setup in a conference setting like this, and number two, about storytelling. And we saw some opportunities to be able to bring these 2 points together. So moving from what Less Guessing had asked, we thought about this, and we've been working on it for a couple of years. So the basic problem is this. At O'Reilly, when we have a conference, you go into a tutorial, maybe there's 200, 300 people. You might spend 20, 30, 40 minutes setting up your laptops to get all of the software needed for that tutorial. And if the tutorial only lasts for 2 or 3 hours, you know, you've burned a third of the time just setting up libraries. And we kept seeing this over and over, that there was a lot of time wasted. We tried to use tools like Vagrant. Has everybody here used VirtualBox, Vagrant, these kind of things? Okay, yes, that's pretty popular. There's problems with Vagrant. You know, you've got to be really careful. You've got the right releases for the right features, and people don't want to reinstall it. Getting VirtualBox downloaded, of course, is a really huge download in a conference setting, and the Wi-Fi is usually not that great. So we just saw that this is a real bottleneck for people being able to learn in a conference setting. And we thought about what was going on with Docker, and we tried to imagine, is there a way that we could put everything you need for a tutorial inside of a Docker container and then just have a web page where you can access that? And while we were working on that, we also were thinking about Jupyter Notebooks. Is there a way that we can integrate Jupyter as well so that people could come into a conference and just hit a web page and already have code set up with the entire environment that they need? So some ideas about this. Andrew Odawan is really the person who spearheaded this. He's the CTO at O'Reilly, and I've been working with Andrew on it for a while. And here's kind of a position paper about how he was envisioning these different types of frameworks being used in media. This is from a couple years ago, and it talks a lot about an experiment that we did called beta.o'reilly.com. It was a new revision of our user experience, our web design. Along those lines, then, we kept iterating. We tried some different experiments, and we came out with a new kind of medium that's called Oriole. We released this in March of this year, although it's been in development for over a year. We've had a few. And the idea of Oriole, I'll show an example here. The idea is that as someone at a conference or somebody reading text online, you can go and hit a web page in your browser. You load that web page. It creates a web session. Meanwhile, in the back, we're spinning up a container in our cloud, or a cloud that we're using. We're spinning up a Docker container for your session. So you have a personalized environment. And in the web page, you've got the text of the tutorial, but you've also got a video, and then you've also got the code interspersed. So we can have the text and the code drive the video, or we can have the code or the video drive the text and the code. We have a timeline that synchronizes those. And with the code, you can go in and run it. You can also go back in and modify it and try what if, or maybe change some of the parameters on a machine learning model, see what happens. Everybody has their own personal environment. But the thing is, you don't have to download anything, you don't have to configure anything, you don't have to install any libraries. It's all just right there immediately. That's what we were trying to do to get around the bottleneck in conferences. And we see this being a problem that's encountered elsewhere. We see this certainly in university settings, certainly in industry settings for training, a number of different places where we believe that this can be applied. So let me jump in and show right here. So I'll show a tutorial. The first one we published was from, is made by Peter Norvig. He's head of research at Google. And Peter had, how many people here have ever seen XKCD comics? Do you know? Okay. So Randall Munroe writes XKCD, and real famous. He's really great programming jokes and whatnot inside of XKCD. A lot of very biting humor. Randall had published one about how to get the minimum size regex, regular expressions, and he posed it as a kind of challenge, as a kind of programming contest. And he'd written up a comic about this. And Peter Norvig was introducing Randall at a conference, and he was looking at the comic, and he recognized that some of it was wrong. He needed to fix it. And so Peter went out and created a Jupyter notebook to show how to fix Randall's code. And it kind of exploded into this larger challenge. And at Jupyter, whenever Peter updates his notebooks, their servers melt down. It accounts for half their traffic. So Peter Norvig has been very, very popular working with Jupyter notebooks, and even to the point where his really popular machine learning or AI text it's very popular. The supplements to it now are being published as Jupyter. So this was supposed to be purely browser-based, zero install required. What we found is that it has much higher engagement metrics. There's none of the other aspects of it we can show, but let me just show an example of how this runs. Oh, come on. There. Okay. So if you want to check this out, the URL here is o'reilly.com/learning/regex-golf with Peter Norvig. And there's a video, so we show this up at the top, but there's a video that's running along here. There's also a timeline on the side, so if you want to skip to a section, you can just click on it.
I said, well, I might as well publish this when I'm done.
Oh, there we go. Okay, Peter's saying something. So we have a timeline on the side, or you can just scroll through. I'm going to start it up at the top here and show how this runs.
I'm a computer scientist. I'm author of some computing books, and I'm currently director of research at Google.
Can you hear that?
Today I want to talk to you about programming and problem solving and exploring through problems. And in particular, I want to look at this problem that came up in this particular comic by Randall Munroe called XKCD.
Okay, so I'll scroll through here a little bit. We get into the notebook part of it. Peter has some setup. He has a couple of minutes where he's describing this. Let me scoot through down to here. Here's the comic that Randall had originally published. And here's some of the early regex that he'd shown. So I'll skip down to here.
Comics. I read it every time.
Oh, come on. Here we go. Let's skip down to here.
Comes out.
So what this is about, the programming challenge is that there's a list of the US presidents, and so it's a text string. And you want to try to figure out who got elected or re-elected or not. And there's a regular expression that can show who are the winners of the elections, who are the losers of the elections. And it's all just based on how their names are spelled. But the challenge is to try to get the regular expression to be as small as possible. So in the Python code, here's the setup for it as Peter described it. And again, all Peter had to go on was this comic, and then he just started writing this code to show it. So I've got this code block here, and I'll click Run. It'll start up a server. It's got a container running on our Mesos cluster on AWS. And so Peter talks about, okay, we want to try to distinguish between these two sets. We have the set of winning presidents and the election losers. So we want to show those. So boom, we can take and look at doing an intersection between them. Or we can do a little bit of set math here. So Peter is going to go in and define the problem. He's got a couple of functions here in Python, and then he's going to try running this against what Randall had written in XKCD, and he finds that there's a discrepancy. And then moving on down here, I can pick up the video.
But this one, number 30.
Oh, come on, okay. So for some reason, it's not picking up the video quite right there, but I can scoot through the code blocks. So I can go in and I can evaluate this. Let me find one that would be interesting to change. I'm going to run down here. Okay. Now, Peter's going to put together essentially a unit test framework to be able to prove that you're making some progress on how optimal your regular expression is. So he sets these tests up and has a way to be able to do some evaluation. So as you can see here, when you run the code, then the output comes out in a block underneath it. And that's typical of what you'll see with Jupyter. Again, this is in Python code, but it could be anything. It could, or anything that has a REPL, it has a Jupyter kernel created. I'm going to go in and change the code here. If I wanted to, for whatever reason, I could just say print foo. And if I run this, boom, it'll come out. So the idea is that even though this is a web page, I've still got this environment running in a container back in the cloud. I can go in and change the code. I can modify it. I can play what-ifs, move around some of the parameters. I've got a computing environment. So there's a number of these here. I can just scoot through, or I could go down the bottom. It also involves some Star Trek data sets, on and on, but it's a lot about regex. Now, this was the first one that we did, but we've done several since. Here's one that just came out yesterday. It's from Aaron Schumacher, and it's about TensorFlow. It's an introduction to using TensorFlow, and this one is written, if I recall right, you see, yeah, this one's going to be in Python too. We've had some that just came out in Scala, some in R, some in Julia, but we're also looking at other languages like Go. So if you'd like to get a good tutorial on TensorFlow, that's a very topical thing. Aaron is at a deep learning company in Washington, D.C., and he's a very good expert in this field. As far as the orioles that we've done so far, there's about a half dozen or so that we've published. Peter Norvig, there's a great one from Luciano Romalo, who's part of the Python Foundation. Luciano goes into really great examples of how to work with Python classes. I learned a lot from watching that. Here's Tom Asperger, something recent in terms of how to bridge between scikit and pandas. So, you know, there's a range of different kinds of topics, but again, you've got this component of video and computable content code, as well as the rich text. And then you keep it all together in a container. So we're trying different ways of mixing and matching those. Okay. Now, one of the things about this kind of medium that we found is, I guess probably, I'll go on this one first. You know, we have a lot of great people who are writing books or making videos at O'Reilly, but we do find that the people who are out there creating these open source projects, the people who are real experts in these different areas, they're very busy people. And so to take off 6 months from work to be able to write a book, that's a big investment. Even to take off like a month to create a full instructional video, that's also a huge investment. Working with notebooks, though, it's about article length. I mean, it might take a few hours to write it if you have some code already to adapt it into a notebook. It's not a huge amount of work. The amount of video that's involved, it'll range somewhere between like 20 to 40 minutes. It's fairly brief, fairly informal. We can shoot a professional video, a 20-minute segment. Our studio team will do that probably in one take. We might do a little adjustments, but they're very informal, they're very quick. So in terms of the author's time, maybe only an hour for them to be in front of the camera. So to look at this delta between spending 6 months to create a book, or maybe just a matter of a couple days to create a notebook, it's a very huge difference. Because we do find that you know, people's time is very valuable, and these experts are very hard to get. So how could we make this something that's easier for them to be able to produce? How can we make something that's easier to get out to the market, to publish much more quickly? And also, what is something that's much more direct and hands-on for the audience to be able to use, to really be able to leverage? These are the kind of motivations that we had when we were creating this. So, you know, some points about this, though, that are maybe a little bit non-intuitive. Jupyter notebooks, I'll show examples of this. We'll create some here in a moment. The notebooks are really based in browsers, and they have a kind of user interface. We don't ever show that. As I showed with Peter Norvig, it's HTML. It uses our style guide. It has, you know, all of our design. It's not the actual notebook. Instead, what we do, because Jupyter is a protocol of network, sorry, it's a suite of network protocols, what we do is to create essentially middleware out of Jupyter. So rather than using the notebooks directly, we take the notebooks and we ingest them in our publishing process, and we run them as middleware. And so for each code cell, we're projecting off some HTML. It's like having an HTML player for YouTube, essentially much the same idea. And then we take those HTML divs and we put them all together in one page. So we've got essentially these different players for the code. We also have the player for the video. We sync them together on a timeline. And that's how we compose an HTML page. So the user experience then is all 100% HTML. And it's a little bit different than what most people are using Jupyter with, but it actually is pretty faithful to what Fernando originally described when he was trying to put this together. Another thing is that in terms of publishing, we like to have notebooks have a certain kind of scope, and we call it a unit of thought. And the idea is for a speaker, such as Peter Norvig or Luciano Romalo or some sort of expert, if they were going to come in and give a 20-minute talk, like a session at a conference here, they would express an idea, they would explore it, they would have some examples. It's not book length. It's not a full video, 6 hours of video or so. It's more like 20 minutes, but it's a thought that's completed. So we try to push our authors towards focusing on something really constrained like that. It's a different kind of editorial process. It's been a little bit of a learning curve for our editors to become accustomed with this, but we have found with authors, they're definitely liking the fact that this is much more rapid, much less time involved, but they're also learning how do they orchestrate being able to speak in front of the camera, but also show some code running, and also have the text. So there's a little bit of an art to be able to create, let me go back here to Peter's, being able to create a presentation where you're talking in front of the camera, but at the same time, people are reading text and running some code. Being able to orchestrate that as a speaker, it's a little bit more like a stage performance. Peter Norvig, he was amazing because he understood this intuitively. He did this all first take. There were jets flying overhead. We had to filter out. It didn't bother him. And the whole time, he was having a sidebar conversation about theory of education or something. So, I mean, he could understand how to orchestrate this. He's very used to being on stage. He's very comfortable with it. Other authors, maybe not, so we're having to coach them. But it's interesting when you get into a real kind of multimedia setting, how much the speaker has to think about what they're saying, what arm movements they're making, because you have a very tiny little box there for the video, so you kind of have to be larger than life. But at the same time, what you're doing and saying has to sync with what's in the text. So a little bit of art to that. Let me show some of the architecture. We can cover this a little bit later, but how we deliver this out to the market, though, gets interesting. After we've created a notebook and brought this into our publishing system, after we've created the HTML for it, after we've shot the video and edited that, and we pull it all together, how do we get this out to the public? And so it's the architecture that we had to really spend some time building, and this is, realistically, this is our second or third cut on it. But we think this is useful because it does speak to the kind of big data architectures that we're seeing here. Fundamentally, this is based on Mesos. So I'll take this in level. There's really 3 levels here. At the top, we've got HTML, as I said, and so this is using JavaScript and CSS and HTML and sort of the typical elements that you would use. It's also using an open source video player called Kaltura. This is something O'Reilly has standardized on using. Kaltura has some pretty interesting features for us, a little bit more substantial than what we would get out of, say, YouTube. We also instrument this as far as how people are interacting. We can see how much they're using the code. That's all based off of Keen.io. So there's a lot of data being gathered, and then we can analyze this. It's also a big data problem. That's the top layer. That's the HTML that you're working with. There's a middleware layer where we actually run Jupyter, and that's where we use Jupyter to publish out the HTML. That part of publishing the HTML from the code cells, it's an open source project that we've released. It's called Thebe. Thebe is one of the moons of Jupyter. And so Thebe is able to translate from Jupyter code cells and Markdown into creating something that's an HTML div. And we've made that open. We're going to make some more changes on that, but we really want this to be more of a community project. So a lot of the fundamental parts of this are actually all open source, if you wanted to rebuild this. Now, down at the cluster layer, the third layer, is where we've got Mesos. So we have a cluster running in the cloud. Currently, we're using Amazon and Google, but we've considered others. We had used Rackspace Carina for a while. We have a Mesos cluster. Actually, how many people here are familiar with Mesos? Okay, so I'll say about a third. The idea of Mesos is that you have like a distributed operating system. You have all these individual servers in a cluster. Each one of them is running a kernel, and they can talk to each other through a master. And each one of these servers has some CPU available, has some memory, has some network, has some disk, all kinds of resources. And the different servers essentially advertise that out and say, hey, I've got 2 CPUs open. I could run some processes now. I've got this much memory. What do you want me to run? And the Mesos master will talk with frameworks and say, well, I need to run some processes. Let me send it over there. So it's a way of managing the resources in a cluster. Up above that, there's an open source project also done by Mesosphere that's called Marathon. And Marathon is a lot like, if you're familiar with how you launch processes on Linux, Marathon is essentially running services. So I can tell Marathon, hey, I want to have the following Docker containers. I want to have 5 of these running somewhere in my cluster at any point in time. So go ahead and spin those up. If one of them dies for whatever reason, spin up another one. So monitor it, make sure there's service availability for a certain capacity. And for each one of those, you can give a profile. You can say, okay, I want 2 CPUs, and I want 8 gigs of RAM. I want so much disk allocated, so much network controller bandwidth. But you can essentially specify how much resource will be allocated to that container. And so it's a way of being able to describe what you can run on a cluster multi-tenant and stack them all together. It's perfect with containers because you can say, okay, with this particular kind of container, I only want a little bit of memory and some CPU. With this other kind of container, I want a lot of CPU. And that fits with the tutorials that we're doing because some of them might be showing Spark and Cassandra, and they're very compute heavy. They take a lot of RAM. Others are showing very simple Python. They only take a little tiny bit. So we can specify very carefully what resources are needed and then stack them all up. So we're using Mesos and Marathon to manage those resources. We're using Docker for the containers. And then we're using Redis and Nginx to provide a kind of security application gateway and maintain the statefulness of the cluster. Am I? 5 minutes? OK, 5 minutes? Did I skip that? Is it less than 5 minutes? OK. OK, a little bit of history, and then I'll go into the last part, because we're wrapping up. A lot of the ideas here of computable content, I'll attribute that to Lorena Barba, and there's some great links from a talk that she did at PyCon last year. But a lot of this goes back to Don Knuth. And so if you look at Literate Programming by Don Knuth, he had some of these ideas that he had articulated, I believe, back in about 1993. And the main idea was, instead of focusing on computer programs, instead of telling computers what you want them to do, focus on telling other people what you want the computers to do, and have the computation be a side effect of how you articulate this, how you communicate this. That's the idea of literate programming. It's more than just having documentation in your code. It's actually having some kind of document that has computable points, but also has a lot of information for people. Wolfram Research introduced notebooks back in 1988. And so this actually, I believe this was before Don Knuth published the book, although it was after he'd done some papers about it. And so Wolfram has had, for Mathematica, notebooks for a number of years. They've done some great work on this. And they really set the tone. I believe in some ways, probably Fernando was inspired by that. More recently, Lorena Barba has been picking up this. I've got a link to her video, also the slides. And I don't have a lot of time, but long story short, she goes into work by Fernando Flores. So how many people have ever heard of Project CyberSyn out of Chile? Anybody? Back in the 1970s, the Chilean government was struggling with how to use computers to have a kind of data-intensive government. And so they put together a project. It's called CyberSyn. And they had some really amazing theorists working in cybernetics who came in and helped advise the government about how to monitor the economy and how to have updates and data visualizations. And this was great stuff. It was in the 70s. They had one dial-up link, and they had some time sharing on a mainframe. very small computer relatively. And they actually did the visualizations by hand. They had artists doing the visualizations. But they still had this amazing project going on. It was unfortunately shut down because of the coup. The US government went in and did regime change. Fernando Flores became a political prisoner. After a number of years, professors at Stanford and Berkeley were able to help get him released from prison. He became a professor at Stanford, and he helped advise on some of what was going on in early groupware. There are ideas there that are conveyed about cybernetics and linguistics. Lorena talks about this in much more detail, showing it as an example of really how to deconstruct open source projects. So I highly recommend that. It's a lot of the theory behind what's going on with notebooks. We don't have a lot of time, but we have some tips here. We've been working with a lot of authors to publish with Jupyter, and we've found some things that work and some things that don't. So if you're creating notebooks, you might want to check through the laundry list here. Just how to really convey ideas that people can consume through notebooks. And I'm going to scoot ahead. There's some notes here if you want to go through and download this and get installed. The main thing, though, that I want to introduce, we have a new project out of O'Reilly. It's called LaunchBot. If you have Docker installed on your laptop, LaunchBot is a way of being able to manage containers and compose them and run them, but then also run Jupyter within those containers. So it's a very Jupyter-friendly kind of Docker interface. Our authors are using this to create our tutorials. Our editors are using it, and it's fully open source. It'll hook in with your GitHub account, with your cloud account. It's not open source, but it's fully openly available. So that was a lot of the gist of this, is that LaunchBot is the glue between what we can do with Jupyter and Docker and how you can create those, and then eventually how that gets launched out onto Mesos. So we do all our development personally, locally with LaunchBot. Once we've got that described as a container, then we can run it out on Mesos and run it at scale. That's the main points. I think I'm past my 5, so thank you very much. I appreciate your time, and I'll be around if I can answer any questions. Thank you.
Does anyone have any questions?
Thank you for the talk, Paco. One question, how would you compare Juniper with Zeppelin?
With Zeppelin?
Zeppelin, yeah.
So there are a number of different types of open source notebooks that have been coming up. There's Zeppelin, there's a few others as well. When I was here last year, I gave a tutorial about what Databricks does, which is an entirely different kind of notebook. So Zeppelin is interesting because it does optimize for running Scala, for running Spark. It does very well for working with these kind of distributed frameworks, whereas with Jupyter, that's not native, so you have to build it. There's something called Torre that does that, but it's kind of heavyweight, takes a lot of memory footprint. So Zeppelin is optimized in that way. But it's not the network protocols. It's not what Fernando was originally intending. So when we talk about how to use this as middleware, when we talk about how to have the distributed network aspects of it, to do something else, how to customize it, it's very difficult with Zeppelin. So we actually found that we've tried, even though it's very close in terms of descriptions, we found that we just can't ingest off of Zeppelin directly. Also, there's Spark Notebook, which Andy Petrella has out of Belgium. Really excellent work, but also it's not compatible with the protocols completely, and so we haven't been able to ingest it yet. I'd love to be able to do that, but both of those projects kind of took some shortcuts to optimize. And it's really, the network protocols are really the heart of this, so I feel that there's some things lost in that trade-off. Great question. If the next one's coming up, I can scoot out of here. I can take some questions outside if that helps.
Perfect.
Okay, thank you very much.
Thank you.